Hi there, if you remember, the three types of program organization units were explained during the first video. Until now, we were using only the first type. This video will show you how a function can be defined and used to have a more efficient program during a practical project with factory I/O. In the next video, another project will be implemented to use and learn function blocks. Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the plcgoods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, let's start the video by designing a simple industrial process inside factory I/O software. Well, let me add a water tank. As you see, above the tank, there is a valve for filling, and also a level meter which will be used to determine the water level. The filling valve can be controlled by a real number between 0 and 10. You can assume that's a voltage that can be produced by a PLC. Also, meter produces a voltage between 0 and 10 when the water level changes between 0 and 300 centimeters. Similarly, at the bottom, there is a flow meter and a discharging valve. The valve can be controlled by a real number between 0 and 10, and the flow meter will produce a real number between 0 and 10, according to the flow rate of discharging. Now, let's design a simple control box, which will be used to control the water tank. Remember, to change the height of inserted equipment, the V key on the keyboard must be pressed. Now, let's use two potentiometers to control the valves, and also two digital displays to show the water level and the flow rate of discharging. OK, inserted potentiometers support three modes. Let's use the default mode, which produces a voltage between 0 and 10, for the first potentiometer, and to have more complexity, let's select -5 to 5 volts, for the second potentiometer. Note that, the first one will be used to control the filling valve, and the second will be used to open the discharging valve. So, let me select appropriate names for them. Similarly, the inserted digital displays support three modes. Let me select the last mode, integer format, and also select suitable names for them. Alright, I've designed my desired system. Before writing its program, let's test the final project to see its performance. My program includes 4 networks. Let's start with the first one. Remember, the first potentiometer produces a voltage between 0 and 10, and also the filling valve is controlled by a voltage from 0 to 10. So, I can easily use a move instruction to control the filling valve, directly with the first potentiometer. At the same time, the third network calculates the water level based on the level meter signal, and also show its value on the first digital display. Now, let me open the filling valve completely. Okay, let's close the filling valve. Note that, I've used the second potentiometer for discharging, but its voltage range is not suitable to control the discharging valve. I need to change its range. So, I define a function, whose task is changing the scale of its input, based on this mathematical formula. Inside the second network, it receives the second potentiometer voltage, which is between -5 and 5, and converts that to a number between 0 and 10, which is suitable to control the discharging valve. Now, let's open the discharging valve. Note that, the third and fourth networks work similarly. They receive produced signals by the level meter and flow meter, to display the water level and flow rate on these two digital displays respectively. Well, let's open the discharging valve completely. Now, let's turn into the programming step. I've created a standard project like the previous videos. As I mentioned earlier, the received signal from the first potentiometer can be used directly to control the filling valve. So, I only need a move instruction. Remember that the potentiometers, valves, and transmitters work based on real numbers. So, I will use this data type for them. Alright, now, I want to write a program to control the discharging valve with the second potentiometer. But there is a problem. As I mentioned earlier, the second potentiometer produces a voltage between -5 and 5, but the discharging valve is controlled by a voltage between 0 and 10. Therefore, I need a program like this, which works based on this mathematical formula, to change the scale of received input from the second potentiometer to an appropriate range. Like the previous videos, I can write the whole of my program here. Instead of this simple way, I want to show you how a function can be defined and used, to have a more efficient program. So, let me right-click on the application, then select the POU item. As I explained in the first video, it's an abbreviation of Program Organization Unit. As you see, there are three types of POU. Until now, we've been using the program type to write the whole of our programs. I will explain and use the second type, function block, during the next projects. Now, let me select the third type, function. It gets some values, and at least has one output, whose data type must be determined. Let me select real data type. Also, let me choose an appropriate name here. It will be used as the function name and also the name of its first output variable. Note that, I can use another language to write my program. Let's continue with ladder logic diagram. Alright, the new function has been created. First, let's look at the declaration section. It has one output which is a real number. As I mentioned before, a function has some inputs to receive some values. The function inputs are defined here. Also, it may need some local variables, which can be defined here. Note that, local variables will be used only by the created function. I mean another POU like this, won't access them. Now, let me write my program, which will use this mathematical formula, to change the scale of its input. Based on the formula, my function needs the minimum and maximum limits of its input and output. Now, let's use the math operators which were explained before, to implement the formula. Alright, this variable is an input of this function. So, after determining its data type, I must select an appropriate scope for that. Now, let's click on OK. This window says this variable is going to be added to my function as its input. Again, let's click on OK. As you see, the new variable has been considered as the function input. Similarly, the next input, the lower limit of the input variable, must be considered as the function input. Now, on the other side of the subtraction, I need a local variable to store the result. Now, let's use another subtraction to calculate this part of the mathematical formula. As you see, new variables can be defined during the programming step. Now, let me define all of them inside the declaration section, and then continue the programming step. Well, for the last variable, I've forgotten to select real number as its data type. Now, let me define my variables and then use them to implement the mathematical formula. Okay, let's continue the programming step. Alright, this is the desired result. Therefore, I need to use this variable, which has been selected as the function output. Now, let me show you how another output can be added. Let me extend the program. For example, if the input signal is not between its valid range, a bit of memory must be activated to indicate there is an error. Alright, to consider a new variable as the output of a function, its scope must be changed to var_output. Well, my second output has been added. Its data type is Boolean. Now, let me complete my program. Now, Let's compile the project, to ensure there isn't any error. Okay, let's go to the main POU. As you know, PLC starts its work from the first network of this POU. Therefore, if I don't use my function here, it won't be executed. As you see, a category has been added to the right list. Here, I can see and use my function. Well, apart from the first input which is used to enable my function, it has 5 other inputs. I will connect the first input to the second potentiometer. As you know, the second potentiometer produces a voltage between -5 and +5. Let me enter them as the function input. Also, my desired range for the function output is 0 to 10, to control the discharging valve. As you know, the selected data type for this variable and also these, is a real number. Just to indicate this point, I prefer to write the number 10 with its fraction part, which is equal to 0. On the other side, I'll connect the first output to the discharging valve. Remember, it can be controlled with the voltage within this range. Although, I won't use the second output, but I should define a Boolean variable for that. Alright, again let me use my function, to receive the level meter signal, whose voltage is between 0 and 10, and convert it a real number between 0 and 300 centimeters, which indicates the water level. Okay, here I have the water level in real format. But these two digital displays accept integer numbers. So, I need to use a conversion instruction which was explained during the previous video, to convert this real number to an integer number, and then, send it to the first digital display. Similarly, let's write a program to get the flow meter signal which is a real number between 0 and 10, and then convert it to an integer number between 0 and 30. Alright, after designing my system using factory I/O, and also testing the final project, I've finished the programming step with CODESYS. Therefore, all necessary steps related to my project have been done, except the connection process between my program and factory I/O. Because the connection process was explained during previous projects, let me increase the speed of my video, just to show you the connection process. If you don't have any problem with the connection process, you can stop the video, otherwise continue watching the video, or use our previous videos to learn it completely. Alright, the project has been tested in the beginning. I hope you have enjoyed the project. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.